After a 2-year COVID-imposed hiatus, we're back in Nürnberg. The sun is shining, which is also odd because normally it's snowing in February, but we're here this time in June. Doesn't matter, we're going to look at new microcontroller solutions, innovative power, machine learning and AI at the edge, and also find out about innovation in motor control as well. I don't want to keep you any longer. Let's go and find out what's inside this incredible show. Now, the Internet of Things requires energy in order to operate, and that's very challenging in some applications because we can't rely on batteries as they need replacing at some point. This is where Nowi comes in. Based in the Netherlands, they're developing power management ICs or PMICs that are able to turn energy from other sources like light, heat and vibration into the energy needed by IoT applications. And they've got some demonstrators here showing how that could work for your classic TV remote control and even signage for your supermarket. So it's great to meet you here at Embedded World this year. Could you tell us a little bit more about Nowi and where you're based?
Yes, of course. So Nowi is a fabless semiconductor company. We are a scale-up based in the Netherlands. It's a small city called Delft in the Netherlands, and one of the reasons why we are based there is because we are close to the Delft University of Technology. It has one of the best microelectronics labs and research groups in the world, and some of our IC design talent pool also comes from there.
And what sort of products have you been developing?
Yes, so we are mostly in the fabless semiconductor market, and we in the power management IC market. We have two products at this point of time. One is in mass production. It's called the Codium, or the official name is NH2D0245, and that is right now in millions of production. It's a really small bare bone power management IC which goes into extremely cost space constrained applications, like for example think about IoT small sensors. That's the first gen product that we have, and the next one that we are currently sampling, it's called the NH16 or the Diatom. That's a more feature packed set of power management IC with energy harvesting. It can harvest energy from any source, starting from solar to TEG to also with some external component from AC sources like RF and like vibration. What it has along with the power management, the harvesting capabilities, is also a lot of power management features. So it has regulated output, it has LDO, over voltage protection, under voltage protection, things like those. So it's a full feature pack system which can replace the current gen power management IC while bringing energy harvesting capability to your solution.
Now, obviously, energy harvesting comes in lots of different forms. What sort of energy harvesting sources can be used with your devices?
That's a very good question. So, of course, our device is agnostic of the kind of energy harvesting solution that you, or the source that you want to use. Having said that, what we see currently in the market and also with the availability of energy is light energy is the most dense in terms of the amount of energy that you can harvest. So we propose for most commercial applications, if possible, to use light or solar energy. Now, having said that, it doesn't have to be sunlight. It could be any kind of light, like the light that we are in, and that's quite a lot. But in certain kind of specific industrial application, we see that where maybe there is a specific thermal gradient, it's a very good system to use a TEG based application. Or if we know a machine is vibrating in a very certain frequency, in a very certain way, it is possible to use machine vibration or piezo based application for cases like vibration sensors. And the last one that is currently a lot being researched right now, especially for its low energy density, the point that I mentioned previously, is RF. There is a lot of interest in the industry, a lot of news. We have also been researching it quite thoroughly to figure out how can we make RF commercial, how can we have enough RF energy, because we have it all around us, but it would be great to use it. So starting from light to RF based on the amount of energy density that is, but most commercial application with energy harvesting we see now is light based.
Now, energy harvesting obviously requires that energy is stored temporarily for the moment when it's actually needed by the application. Can you tell us about some of the partnerships you've been making on the storage side?
Yes, of course. So we have been working with TDK. This is really interesting because they have a new kind of solution called SeroCharge. It's a silicon-based battery. It's extremely small, and it's really safe to use. It doesn't explode, and the kind of problems that typical lithium polymer batteries come with. And we have have a demo here at Embedded World today as well for that one. Along with that, we also work with all the leading battery and silicon capacitor companies that are available right now. So starting from Panasonic to any other battery company that you can name.
Sounds fantastic. Well, we wish you all the best with the show this week, and look forward to seeing what comes out of Nowi in terms of new products in the coming months.
Thank you so much.
Now, at the low end of processing performance, there are plenty of microcontrollers to handle your application. But when it comes to high performance computing for edge and autonomous driving, artificial intelligence and machine learning algorithms need some really meaty processors. I'm here at ADLINK to find out a little bit more about their high performance computing capabilities, their GPU modules, and how they simplify the supply of industrial displays. So it's great to see you here, Zane, at Embedded World this year. Could you just start by giving us a bit of background as to what ADLINK does?
Okay, ADLINK is an industrial PC company that with over 25 years of the experience in the embedded computing, but there's still a trend for moving forward from embedded to the edge. We see the importance from how to manage the data generation, how to do the data analytics, and how to bring the actionable insight to the operators and bring in and generate the value. That's important things. So that's a trend we're moving from embedded to the edge computing. That's ADLINK.
So at the edge, obviously, that means different things to different people. In the space where ADLINK provides modules and support, you really have some quite hefty high-performance computing solutions.
Right.
So what's happening in HPC at the minute at ADLINK?
Yeah, of course, when you talk about edge or embedded, the typical stereotype that is something small, right? Something based on low power consumption, low computing power, but application specific one. But given that nowadays, the edge computing brings in the different idea, because the major idea for edge computing is to respond to the data timely. So it's not only for a smaller one, but also they're considering something bigger and bigger, more general. If there's a voice input, image input, and you have a response of that in the different locations, and that requires a higher performance in that computing. And modularization is a very important in embedded, because you want to last long for your applications to get the support, and also the customer doesn't want to be vendor locked in. Okay, so the modularization based on the industrial standards is important for embedded usage. So together, we have higher computing powers, HPC, high performance computing, with the standardized module, which comes to COM-HPC. Okay,
so what sort of applications are these edge modules going into? I mean, obviously there's lots of interest in autonomous driving and autonomous robotics, but also 5G. So how do your modules support those types of applications?
Right. So basically on the COM-HPC, you can see in the standard there's not too many other low-speed IOs. The major idea for the COM-HPC is we have focusing on the computing performance itself, and also those IOs that will be expressed by the PCIe. Okay, so every other IOs will be converted by the PCIe itself, and when that deploy into the applications, you can see that we typically use that into some applications with a relative small space or mobility, or even, but still demand very, very high computing power. So even for the I/O, there will be high-speed one. So starting from autonomous driving, you have a sensor taking the images and processing in the same time. There's a multi-input processing the data. So parallel computing, high-speed I/Os, high computing powers, relatively small, right? And also the autonomous robot, with the big robots that take the different sensor inputs, not only the video, also the audio stuff, and to take actionable some reactions to the response or request. And especially in the medical imaging, like the CT, MRI, you don't expect a very noisy or very bulky design in that space. Nowadays, they want something relatively compact, but still have ample computing power to support that kind of processing, medical image processing.
Now, there are continual advancements in the digitalization in the field of medicine, trying to provide better visual tools to detect illnesses before they progress too far. But on the flip side of that, we need GPUs, which typically don't have a very long shelf life, especially in the consumer space. I put that question to Zane to find out how they provide longevity of supply for medical imaging applications.
ADLINK has a special contract signed with NVIDIA. So now we have a guaranteed supply from NVIDIA for this GPU itself, and we take care of the rest by ourselves. You know, we have 25 years in the embedded computing. We do know how to support longevity stuff. The only thing we need from NVIDIA is the support from GPU. And we're the only one of the handful of embedded partners that NVIDIA has in this market. So our module starts, the longevity for our module starts from 5 years, okay, and that can be prolonged. If the customer has some special demands, that we can even support something even longer, 7, 8 years, even 10 years. That can also be discussed.
Now, one of the challenges for industrial engineering companies is sourcing all of those components, and we see some real problems during the corona crisis getting hold of semiconductors. One of the things that ADLINK does for their suppliers and customers is bundle everything together in modules. That simplifies everything by taking lots of suppliers out of the equation and bringing them all onto a single board. We talked to Zane to find out how that works for industrial displays.
So now ADLINK plus AUO, we bring in the simplicity for the customer to choose for these visualization systems. So actually the main thing this year for ADLINK is, you know, we have 25 years embedded, we bring mission critical stuff into everyday devices. Now, that sounds complicated, but we try to make it simple and smart. It's a KISS idea, okay, a KISS, keep it simple and smart. Okay, that's the idea of that. But how we do that? Because we know choosing the layers for building the visualization system can be complex. For example, what's the LCD viewing angles? What's the brightness you want to choose from? How does the backlight last? And what kind of color support resolution you want from the LCD. Not to mention, also the touch sensor. Do you want to wear the glove to access it? How many points of the accessibility? And do I have to fine tune the sensitivity of that? And when we consider the glasses itself, does it have to be vendor proof? How's the thickness? How's the ruggedness of that glasses? That's all application specific. Not to mention, we also have to integrate them together. There's optical bonding, air bonding, different kind of bonding. So in old days, the user have to source each layer by itself. Okay, so the glasses, the bonding, the sensors, the LCD by themselves. But now with ADLINK plus AUO, you have this made together. We call it Panel Plus. Okay. The function module keep the state-of-the-art and verified computing board, and allow customer to build, customize, or we can customize for customer for their application-specific I/O. So we expose the native interfaces and convert that into the application-specific I/O by the ASIC on the function module board, which creates a huge complexity for customer for the different applications. Okay. And as you can imagine, we also have a strong GPU support. So you can easily consider that ADLINK is capable to bring the GPU support on the function module and bring it into the panel.
Now, one thing is clear here at the NXP stand. The engineers have not been sleeping for the last 2 years during COVID. They've been beavering away. They brought out a completely new scalable microcontroller architecture known as the MCX family. That goes from small, low-power devices right up to high-performance microcontrollers that are even capable of supporting artificial intelligence and machine learning algorithms with dedicated hardware on chip. I was talking to Ali and Cristiano about that, and that's a fully supported platform through their MCU Expresso development environment. So you can get started straight away developing an environment that you're already aware of. Now, those two processors come out of the learning from their traditional controller families. That's things like the LPC family and the Kinetis family. And they've taken those low power capabilities from Kinetis and the high performance support solutions like DMA and I2C buffering out of the Kinetis family and brought them together into MCX. So some very exciting new microcontroller solutions targeted really at industrial suppliers who are looking to find a platform where they can really scale from lower performance and low power right up to high performance for the more challenging applications. Now the other big news from NXP came from Brian Carlson. He's there in their automotive team, and they launched the S32E and S32Z real-time processors, and they've just been awarded an innovation award here by the Embedded World team. And it's no wonder. These processors are targeting the software-defined vehicles of the future. What we're going to see is, instead of having one box per feature, say a box for an airbag, a box for a window lifter, a box for a braking system, we're going to see all of those functionalities integrated into one box. And that requires lots of performance, but also lots of safety, the ability to ensure that one piece of software that's running on the controller doesn't interfere with another piece of software. Their processors have up to 8 cores, which are high speed, high performance, and they can even be lockstepped in any combination that you want to provide that safety. In addition, it also has a pair of Cortex M33 processors, which support the whole ecosystem. It's just incredible how high performance these are. They also run up to 1 gigahertz, and that's really something big with plenty of flash memory, plenty of SRAM, and support even for LDDR5. So this is really smashing the ball out of the park for automotive developers. So hi Daniel, thank you for taking the time to talk to me here at Embedded World this week. We're here at the Silicon Labs stand, and what I wanted to start with is to understand what it is you've been doing for the last 2 years and what you're now presenting to us at Embedded World. Now we've been able to come back and enjoy the show.
Yeah, thanks for having me. It's great to be here, and it's been quite a couple of years. But so what have we been up to? We make chips that make it easy to connect things to the internet. And really, in the last couple of years, especially with the supply chain crisis, we've seen our customers really come full force to us and say, connectivity is in our future. We need the chips, and we need to make this real now.
So what has been the main focus with the microcontrollers? Here a lot going on around wireless. Is there anything in wireless that you don't cover for IoT type applications?
Sure, so we sell all wireless except for cellular, and we're seeing wireless kind of penetration into embedded systems going into full force. So whether it's integrated on a microcontroller or side by side with an MCU, it's up to the application and the end customer. But the overriding demand is wireless is going into embedded very quickly.
Now, of course, in the microcontroller space, there's lots of different processor cores being talked about now, especially with the emergence of RISC-V, a very interesting open standard. How does Silicon Labs see RISC-V in the ecosystem?
Sure. So we typically sell 3 kind of architectures at Silicon Labs. We have a proprietary 8051 base. We use ARM CPUs, really in the Cortex M class, and more recently we have adopted RISC-V processors. Today, these are mostly captive cores running inside our processors doing specific functions we program them for, and the customer accessible cores remain ARM-based. But we're very excited about what RISC-V is done, invigorated the ecosystem, and can't wait to see more.
Now with IoT applications and wireless, one of the big challenges is powering those devices, and nobody wants to be going out into the field to replace batteries. So what's going on in the space of low power? And obviously there's that distinction between static energy consumption and active energy consumption.
Yeah, so we did some calculus a while back and showed that it would take billions of people years, just replacing batteries, and how much of the global economy that would be. That's obviously not what's going to happen here. We care about low leakage as well as the active power you're describing, not just in processing, but also in the wireless communication. If you're going to be sending wireless signals, you have to power up a power amplifier, and that's just physics at that point. So we really take a holistic approach here and try to drive multi-years on a battery, or even energy harvesting is starting to become big, thermoelectric, vibrational, piezo-based, all kinds of energy harvesting is coming, even RF-based. So we're really excited about kind of how low can you go, and bringing traditional high power compute into battery powered, not just driving battery powered lower, like machine learning on a coin cell batteries in our future.
Fantastic. Well, it's great to hear your insights on low power, Internet of Things, and the solutions that Silicon Labs is bringing onto the market. We wish you a fantastic show here at Embedded.
Thanks for having me here.
Now, there's plenty going on Embedded World on the trade show floor, but sometimes specialist groups want to get together outside of the fair. We went to speak to the IoT Stars organisation. Now, they're a group headed up by Laurens Slats. He told us about what IoT Stars is, and we also looked at the launch of a new company, Nubix, run by Rachel Taylor, and asked her why containers are needed in microcontrollers. So hi Laurens, great to see you here at IoT Stars this evening. I'd like to start off by understanding what is IoT Stars?
So IoT Stars is an IoT community and we host exclusive events. That's the most of what we do. I think the problem that we see is that everyone tries to build their own islands and only focuses on developers using LoRaWAN, or only developers using cellular, or only developers that use Zephyr. And we try to kind of facilitate the bridge so all of these worlds start talking together. Because eventually we're aiming for the same thing.
And so what sort of companies have come here tonight to listen to the presentations and meet and network?
Yeah, so we had quite a few good companies. So we had Blues Wireless, really nice startup, mostly focusing on cellular IoT. We had IoT Creators, which is kind of the spin-off from T-Mobile. We had Koitech. It's going in depth about battery analysis, so really engineer focused. And we also opened the floor for startups, so we had Nubix and Goliath. Really new in this space, and they're trying to focus on embedded developers, building tools to make their life easier.
It sounds really exciting. I'm sure people would want to join in and participate in future events. How do they get in touch with you?
So I know we show up in different events, different locations around Europe. Anything can be found on the website iotstars.com. So we'll be there at Electronica, we'll be there at Mobile World Congress, we'll be there at Embedded World. We're still thinking about some other events, but it's anything that's hardcore technology and where there's a clear bridge between IoT, we're there.
Super. Well, thanks very much for taking the time to talk to us and share us the IoT Stars concept. I think it's a great opportunity to bring people together, and we need more networking, so great stuff.
Perfect. Thanks, Stuart.
So hi Rachel, lovely to meet you here at IoT Stars. I hear you started a new business called Nubix, and I'd like to know a little bit more about who you are and where you're based.
So Nubix is about 4 years old. We are venture-backed, traditional VCs, as well as we have one corporate, which is Chevron. We are remote, so we are a fully remote organization. I myself am in Bend, Oregon, and then we have people all over the United States.
So, and what's the sort of the technical challenge that you've taken on at Nubix?
So Nubix is really focused on making those 2/3 of the devices that live at the edge, that are connected to the sensors, right, that are collecting data all day long, that needs to be leveraged and actionable. We're focused on making those microcontrollers agile so that you can actually use that data in a meaningful way, but it's not painful, it's not hard, it doesn't have all this friction that you see in IoT, which is why IoT is so far behind, right? This Industrial Revolution 4.0 is far behind,
Very
and it's because,
stiff.
yes, I think it's stuck, is what it is. And so Nubix is really focused on trying to unstick it and get it moving with technology that people already use and understand every day. They just don't use it for these devices right now.
Yeah. So one of the areas, or the core of the platform you're developing is sort of containerization, and that's really something that people are more used to in the Linux world with big servers. I can share one resource, one PC or server, and allow several applications to run on it without interfering with each other. So how are you applying that to the microcontroller world?
Yeah, so, well, and containers actually take virtualization a step further, right? So what containers do, and I like to use Tupperware because everybody knows what Tupperware is, right? A container is just like Tupperware, right? If I want to take my salad with me, right, I'm going to put all my salad stuff in there, I'm going to put my salad dressing in there. When I get wherever I'm going, number one, I know everything I need is inside of that, right? So all my dependencies, all of my APIs, my libraries, everything I need is inside of that container. Makes it portable, just like Tupperware, right? But it also makes it so that I can build it once and deploy it across thousands of servers in my cloud infrastructure, right? So if you take that same framework and you think about, I have 1,000 trucks that are all over the United States right now, hauling cold supply chain, pharmaceutical ingredients that have to be kept within a very tight range on their temperature. Okay. How do I manage those? How do I know that they're working? How do I know that the sensors are reading properly and that those loads, which, a load of caviar is $1 million, right? One truckload of caviar. How do I use the data on that sensor to be able to know what's happening across that 1,000 trucks that are moving all over the place, right? Especially when they're not in a place where they have connectivity. So if you think about containerization, so being able to deploy an application whenever I need to, right, safely, one-to-many, is really necessary at that microcontroller edge. The problem is I can't do that right now, right? I've got to build a firmware image, I've got to push that firmware image over FOTA, I might brick the device, now I've caused myself a new problem, it's slow to develop. So containerization really starts to remove a lot of these friction points and allows me to leverage that compute and make decisions in real time, not 2 days later when the data finally gets to me and I clean it and I look at it and I get it all into the same platform because it's in all these different OEMs platforms. And so those are some of the types of challenges that containerization solves, but not containers that people will use today, right? Not Linux-based, because these devices are all RTOS.
Exactly.
So Nubix has built the same type of technology that you use in the cloud, but we've built it for RTOS-specific machine or compute devices that live out at the edge.
So obviously, as you said, an RTOS or some kind, an operating system of any kind is needed in order to support this. Which sort of operating systems are you supporting at the moment or focused on?
So we've done Mbed, which is ARM's proprietary RTOS. We've done free RTOS. Next up is ThreadX, which is now Azure's, they acquired it. And then Zephyr is on the list after that. So we've got a few, right? And those can come online really quickly. It's really based on kind of customer needs as far as how we prioritize those.
Now, another important part of that over-the-air update process is, of course, some sort of cloud solution to be able to find the nodes and push the update out. Do you support that part of the system as well?
Yes, absolutely. So we've been integrated fully with Azure, and now we are fully integrated and hosted on AWS.
Right. Okay.
So this new soft launch that we have in the next couple months is all AWS hosted.
Now, as you said, you're in the startup phase at the minute. I'm sure there's definitely some people out there desperate to give this a try and find out more. How can people participate? Is there a beta program?
Yes, there is actually. So if you go to our website, there is a join launch button. You click that button, it'll ask you for some information. We're going to follow up. Just make sure that your project makes sense, because we're obviously on a few selective boards right now. STM Micro is our board right now that we're on, and Cortex-Ms. But there's some other options that maybe could make things work, but we just want to check and make sure it's the right beta program for everybody.
Well, it sounds very exciting. Thank you for taking the time to talk to us.
Yeah.
I know it's very busy at Embedded World Week this week, and we wish you all the success for the project, and I hope we get to chat to you again next year and find out what a success it's been.
Thank you. I hope so. Thanks, Stuart.
Now, motor control is notoriously complex application, not just for standard DC motors when we get to PMSM motors on vector control. they just don't know where to start. But luckily, Microchip is a new solution. They've combined the SciLab, sort of open source type of MATLAB technology, into MPLAB to make motor control much simpler to implement. And not only that, they've integrated AI and machine learning to detect when something's gone wrong with a motor. I spoke to Christoph here at the Future stand to find out more.
Hi Stuart, yeah, thanks. I'm showing the latest motor control demo we have prepared for Embedded World, which is a standard sensorless field-oriented control algorithm that includes AI/ML for detecting anomalies like broken bearings, unbalanced load for predictive maintenance.
That's really exciting because predictive maintenance is obviously a really important topic. We want to be able to tell when the motor's damaged before it goes completely wrong so as we can repair it. So what have you been doing in the software development tool chain to integrate that into the development process?
Well, we are working together with our design partner Stream Analyze. They are responsible for the AI/ML part. We have integrated into the FOC algorithm the AI/ML by only using already available information in the FOC algorithm. So no additional sensors like acceleration sensors or microphones are required to detect the anomalies.
Now, one of the big challenges with motor control is obviously the algorithms modeling the motor. How have you improved MPLAB, your development environment, in order to make it easier for motor control developers?
Well, we are using our rapid prototyping environment based on SciLabs, which is a free software tool. We have integrated this into MPLAB X with Harmony 3 and with our MCC configurator, so we can completely model motor control algorithms, including the motor, including the load profile, and we can completely simulate applications on the PC. And once we are happy with the simulation, we just click on a button and C code is generated out of the model and directly programmed onto the microcontroller and it's spinning the motor.
Now, those people who've used microchip controllers in the past will know that you have devices which are dedicated to motor control. Is this limited just to those devices?
Well, the solution itself supports any 16 and 32-bit microcontroller from Microchip and also any application. So it's mainly for control algorithms, but it's not limited to motor control at all.
Super. Well, thanks very much for your time. We wish you all the success at the show, and yeah, looking forward to see what comes next.
Yeah, thank you.
Now, embedded developers have a sort of love-hate relationship with their IDE, and at some point they definitely want to just chuck it all in the bin. And that was the experience that was had here by MBeatle. I was talking to Johan Cockx, and their initial experience with development environments from the traditional microcontroller vendors was, let's just say, not that great. They've taken a new approach using an open source development environment which was originally created for Python, and they're making it available for free to developers. They're also based in Leuven, and it turns out they make very good chocolates.
MBeatle is building a new IDE to program just microcontrollers. Most IDEs for microcontrollers are actually general purpose IDEs.
Right.
They were developed to develop web applications, desktop applications. You can do anything with them, and that makes them much too complex. They have lots of buttons and options that you never use when you're programming a microcontroller, and at the same time they are often missing some features that are really important for microcontrollers. For general purpose applications, you usually want to hide as much as possible the hardware platform on which you're running the environment. You're not interested in that.
Yeah.
But for a microcontroller, which maybe a few kilobytes or in a small amount of memory or flash, you are very concerned about your hardware. You don't want to hide that.
Yeah, exactly. Now, I mean, in development environments, obviously very complicated tools to develop. Have you built it upon a standard development environment like Eclipse, or what was your approach?
No, actually we haven't. We wanted to get rid of all the complexities of these IDEs, so we started from scratch.
I think that's a good idea. Sounds good. So obviously development environments are quite complicated to build, and there's obviously different ways of creating code for the different microcontrollers on the market. Which microcontrollers and processor platforms are you supporting currently?
We're supporting multiple microcontrollers for multiple vendors. We have a selection of most important ones, I think, like 7 or 8 different ones. You can check on our website VCRs, and for each of them we have a small selection of microcontrollers.
Yeah.
And we actually trying to partner with these microcontroller vendors to get support for them to have a larger integration of their whole portfolio of microcontrollers if possible. I would really love to do that.
Now Arduino and the other open source hardware platforms are really popular. Is that something you support as well?
Yes, we do have, for example, an importer for Arduino projects.
Right.
And once you import an Arduino project into MBeetle, you can see much more than the typical init and loop function that you see in an Arduino IDE.
Yeah.
You can even see all the library code that is hidden in Arduino IDE. You can edit it, you can see the make file that we use, you can edit it directly, it will never be overwritten. It gives you much more visibility on your project, much more control.
Mm-hmm. Now, one of the important things for developers is to understand what all these things cost. So is there a price associated with the MBeetle IDE?
MBeetle is free for users. The way we want to make money is to make a partnership with the vendors, and we think it should be free for the users, and it's beneficial both for the vendors and for the users to do it this way.
Well, we wish you all the success with the MBeetle IDE, and have a great time here at the Embedded Show, and we look forward to seeing how it develops.
Thank you very much.
In industries where software plays a key role in functional safety, it's important to make sure that everything involved in creating that software works correctly. But how can you be sure your compiler does what it says on the tin? This is where Solid Sands comes in. They do compiler checking, and they also check the libraries that go with C compilers and C++. I talked to Marianne to find out more.
Solid Sands is based in Amsterdam. It was founded by me and my co-founder in 2014, and we have a compiler test and validation suite called Supertest, and besides that we also have a library and qualification suite called SuperGuard.
That's a very interesting topic, because when we look at industries like automotive, for example, there's always this hanging question: how can I be sure that the compiler does what it's supposed to do? Is it turning my C code into assembler? How can I prove that? So how do you help your customers to prove the compiler works?
Yeah, that is a question we often have been asked to us, of course, because everybody has that compiler and nobody wants to do anything with that. So what we say to our customers, we can help you to qualify it with Supertest. They run their compiler on the specific target for their specific use case. And at the end there is a report, and it shows exactly which of the tests are failed and passed, and then they can look at the details behind the test failed and take their actions, either take it out because they didn't use it, and then you have a qualified compiler, and some companies want to go certifying the compiler, and then they can take that report from us to a TÜV, for instance, to have it certified.
Now, one of the other elements of a compiler very closely related to are the libraries. We have those standard things like malloc, alloc, printf statements, all those things that the compiler, they look like part of the C language sometimes,
Correct.
but they're not really, they're code behind there.
No.
Can you help people to qualify those libraries?
Yeah, and especially the libraries are a bit different to qualify, because you need more than just a bunch of tests, what you do for compiler qualification. So for the library we added additional requirement specifications and test specifications within the product SuperGuard, because that's what you need to prove that you did the best you could to qualify the library, and at that point then they can take that to a TÜV and see if they can certify it. Yeah, but the library ends up in the car, so it's much more important to qualify a library.
Yeah. Now, what type of application spaces, what industries are really keen to have those qualified libraries and qualified compilers? Is that everybody, or is it specific types of users?
Yeah, at this point we get the biggest demand out of the automotive market. Robotics is very in need of that, and railway.
Railway as well.
Yeah, that are the most important markets. I know that medical sometimes comes around the corner, but it's there in another level for the qualification.
Yeah. Okay. Well, thank you ever so much for your time taking to talk to us here at Embedded World. We wish you all the best with the show, and hopefully we'll see you again next time.
We hope so too. Okay.
Now, the electronics in automobiles is getting increasingly complicated, and we need to separate software from each other on a single processor, like a system on chip. Companies like eSol provide hypervisors which separate everything out, and they're also seeing increased interest in Rust as a programming language. I'm here to talk to them and find out more.
So eSol is a Japanese company at the core, but we're expanding in all of the world. We have an office based in France where I am, an office in Germany, and we focus on making the edge computing in embedded. We have an operating system called MCOS POSIX, a hypervisor that's an extension of it, MCOS hypervisor, and we also provide services around the operating system, around deeply embedded in the automotive world, in the industrial world, and services also around ROS and AutoWare, which is very well defined for either robotics or automotive.
Now, in the automotive space, over the years we've been used to having one function per box. We have a window lifter, we have an airbag, and what we're seeing at the minute is this software-defined vehicle approach where all of these functionalities are coming into a single box. But then we have that problem that a window lifter has to be functionally safe, brakes have to be functionally safe. What are you doing to make sure that those types of applications can all run alongside each other, and then we can have, say, Linux or Android functionality too?
So we've already been servicing our customers with those critical systems in the single function boxes, and some of them will remain like that. The airbag will still remain the airbag. Okay. However, other functions will be merged together. That's called aggregation, and will just stay the same. And as the next generation goes, the features get intermingled a lot more, and that becomes consolidation. For this, we actually have many solutions. One is the hypervisor and the operating system MCOS POSIX that I mentioned, and we also have other solutions for the automotive world, MCOS AutoStar and the hypervisor for MCU, which allows running on small ECUs, multiple classic platform elements. And as you grow up in the bigger SoCs, that POSIX operating system, hypervisor, and bigger aggregation becomes critical to do the edge computing that I was mentioning before.
Now, one of the announcements you have here at the show, obviously you support lots of different microcontroller platforms, but there's a new microcontroller family that's just received support from EMSOL.
That's correct. So we try to expand and we try to support the whole industry, but it's a continuous work because there's always new chips coming up. We've been working with an XP, we've been working with Tsai, and the new generation that we have at this show is the announcement of the Renesas S4 support, which is the first chip of the generation 4 of the company. At Renesas. We also support other chips already, but they are not announced yet, so come to us and we'll talk to you whenever.
Now, automotive has always been sort of a classic C++ programmer's domain, but there's lots of interest around Rust. What's been your experience so far? Is that coming?
Well, first of all, C and C++ are not going to disappear like that. These, especially C++, become more widespread with the bigger frameworks like AutoSAR Adaptive, like ROS, so that will stay. However, many more people try to aggregate and a lot of new connected applications, and indeed Rust seems to be a trendy one, where the good thing about Rust is you can avoid race condition, and it's also very well designed for parallel compute. It turns out that MCOS is also great for parallel compute because of its multi-kernel design. The key thing that's missing for Rust is the possibility to do safety.
Right.
Well, to embed it, you need a safety OS, and we have that. But then you need also the safety tools, safety qualified tools. So we have been working with a company called Ferrous Systems, who are qualifying a Clang-based compiler for the Rust language, and we're already having a possibility to run Rust with their compiler on MCOS.
Fantastic. Well, thank you for the insights as to what's going on here at ESOL and the stuff you're presenting here at Embedded World. We wish you a great show, and we look forward to seeing you and catching up with you next time.
It's a pleasure, and well, you can always contact us anytime.
Thanks. One of the big challenges with IoT is powering those devices, because we can't keep replacing the batteries. This is something that TDK has tackled head-on with their Seracharge technology. They've taken the best from lithium-ion batteries and also MLCC ceramic capacitors and merged the two together to create a lithium oxide-based ceramic battery. That can be used for long-term applications in the field, operating at up to 1.5 volts per cell. You can recharge them using PMIC technology from energy harvesting, and the nice thing is that they don't leak and deteriorate over time. They're also capable of delivering up to 50 times their charge rate, making them the perfect power source for Bluetooth low-energy applications. I'm just jumping in here in the middle of this video to say thank you very much for watching. If you like what you see, please subscribe and like. And for your efforts, I have a little surprise for you. I've got 5 Raspberry Pi Picos to give away. Simply use the link associated with this video and the code word resistor. Good luck. Now, as soon as you start to talk about flash technology, the first name that comes to mind in this industry is Toshiba. Toshiba invented flash, but Toshiba Flash is no more. They've been turned into Kioxia. Kioxia is continuing that innovation in the development of flash technology, using their 3D to layer up and get more capacity inside every chip. And the innovation doesn't stop there. They're putting those into SSD formats for laptops, gaming PCs, and other similar applications. And also they're bringing out a new small format exchangeable drive in the form of XFM Express, a new JADEC standard that we're hoping the industry will get behind. I'm here to talk to Axel Stoermanm and find out a little bit more.
Well, as you just mentioned, so it's really a new experience which we make after more than 2 years. And so it's also for us as Kioxia the first time to show up or come up with our individual new look and feel, as we are now representing the individual memory and storage company Kioxia on our own booth with our own new colors and look and feel. That's really amazing.
Exactly, and that's the really interesting thing. Obviously, you were part of the Toshiba group a few years ago. Yes. It's now called Kioxia, right? But you've retained obviously that innovation in flash technology, and I understand that you've also been introducing some more innovation in the 3D BICs, which is the basis of your flash storage. How far have you got with your layers?
That's correct. As you said, so our history and origin is coming from the, let's say, 35 years of experience of NAND flash manufacturing. Actually, Toshiba invented the wheel, or let's say the flash, at that time, and so we can base our production and our designs on a long history and a lot of experience in this industry. So yeah, actually we transform this knowledge, especially our core knowledge on 2D, then transforming to 3D technology to our new company Kioxia. Yeah. And based on this, we are trying to transform our technology or put our technology on top of individual use cases in markets like automotive, industrial, data center, our cloud applications.
Now, one of the challenges with flash was, of course, in the planar technology, it was getting too big, wasn't it? Too big a surface to grow the size of the flash. So you've gone 3D in layers. How many layers have we managed to get to now?
Well, so we started our production with a 64-layer stack, and during the last 2 years we migrated to 96 layers, and now we are coming up with mass production of 112 layers, and for a data center and let's say high-scaled applications up to 162 on mass production.
It's interesting because you see flash as a technology that we all need to use, and you wonder how do you differentiate in that market. There's obviously very clear standards. I think you've got, for example, like SSDs. There's a standard, everybody has to adhere to that. So how can you innovate in the flash industry?
Well, I think one is, of course, to make sure that we follow the standards, that we are compliant to the individual global standards. That is what we do by, let's say, deep involvement on all the standardization bodies like JEDEC, MIPI, or even other standardization bodies, and that secures our compliance. On the other hand, we want to differentiate, first of all, based on our long experience on, let's say, high quality manufacturing, and by offering very high endurance and high performance products. And as such, and we also want to differentiate on the individual use cases in the individual markets, as I said before.
Yeah. Now, sort of compact client PCs have been very popular. They're very small. They don't need a fan, and the memory is typically soldered onto the board, the flash memory, and that obviously limits the lifetime of those products because you can't upgrade the flash like you would do with an SSD drive or some sort of flash drive technology. But I understand that you've been working on a JEDEC standard to make a sort of like an SD card like exchangeable flash memory for those. Can you explain what's going on in that JEDEC standardization process?
Yeah, this is an activity which started around 2-3 years ago already, and it is the new XFM Express standard, which is representing a crossover flash memory, which is, as you said, not really an SSD and not a card. It is not a consumer product, it is not a plug-and-play product, but it offers a kind of modular and card-like form factor, which we can utilize for memory expansions, or even for, let's say, upgrade options in the industrial applications, or even maybe in future in automotive applications also. Especially for software-defined cars, there might be also some room for new business approaches.
Yeah, exactly. Well, it's been great to see you again at the Cockx stand here, Embedded World 2022. Thanks for your interesting insights as to where we are with flash memory technology. And we look forward to seeing the innovations that come throughout the rest of this year.
Thank you very much.
Bringing IoT solutions to market is quite a challenge. There's the radio interface, there's the programming of the microcontroller, and then the connectivity with the cloud. But that's all simplified with a no-code approach here with IoT Eyes. I spoke to Steve to find out more.
So IoT Eyes is a French startup, and with a long experience in embedded systems development and a deep knowledge of those systems. And in about 5 years ago, when we created the company IoT Eyes, the objective was to create a no-code solution for adding wireless into an embedded system. So the company that had an existing design could bring that connectivity, whether they wanted to connect to a mobile phone or a cloud system, extremely easily, and without reinventing their system that they already had.
Now, IoT means different things to different people, and there's obviously some sort of wireless connectivity involved. What sort of wireless technologies do you support?
So IoT Eyes works with a wide range of NFC technologies, and whether we're connecting to, for example, mobile phones using NFC, Bluetooth Low Energy, and Wi-Fi, or for permanent monitoring on a cloud system, we have Wi-Fi. We're adding in LTE Cat-M, LoRa, and we'll soon have a device out with NB-IoT.
Now, how do engineers decide when to maybe go for something like LTE-M or NB-IoT, or maybe just stick with LoRa? What would be your recommendation?
So I simplifies a little bit based on the use case. For us, we consider LoRa to be more of perhaps a site-based type of technology. If you want to create your own proprietary network, you don't want to be locked into the requirements of a mobile service provider, then LoRa is an excellent technology, robust and low power, that you can use on your site. On the other hand, one of the demands that we've had from our customers, clearly for LTE Cat-M, that brought them to that decision, was having mobile assets. So an asset that was going to move from network to network, region to region, and would need that wider support of a mobile service provider, or maybe even multi-mobile service providers to cover a European region, for example.
Yeah. Now we've seen that IoT and connectivity has been a big sort of on the verge of appearing in industry. We've had IIoT, industrial IoT. We've also had Industry 4.0. Are you seeing industrial companies ripping out, or are they retrofitting?
Well, ripping out certainly is an unrealistic expectation, and that's actually one of the reasons why we took the direction we did with industrial IoT, was providing a solution that actually transforms existing what we call field bus technologies to a wireless field bus, to allow that either mobile connectivity, whether that's what the company needs, or cloud supervision. And certainly a much more realistic approach to imagine that they have to maintain for 5, 10, 15, 20 years legacy infrastructure as they progress towards a full IoT or Industry 4.0 type scenario.
Now, embedded engineers are very much used to writing C code and programming microcontrollers, but then it's the link to the cloud, which is often a big challenge. We have data we want to visualize with graphs, then there's the cloud itself with AWS and Azure, which really just seems so far away. I'm not really sure where to start in most cases. How are you helping people to achieve that, and also supporting mobile phone apps as well?
Mm-hmm. And so that's exactly the approach that we took. Was we saw that many of our historic customers were blocked in their movement towards the IoT. First, what did it mean? But more importantly, what are all these technologies that they had to get their heads around and actually had to master in order to do that? And that was the idea, that's where the idea originated, to bring them a no-code solution where we pre-implemented everything from the wireless protocols and wire protocols, the security mechanisms, access control mechanisms, and data handling. So they didn't have to go in and invent all that stuff themselves and master all that themselves. Now, certainly there will be some who want to refine perhaps what we do, but having a no-code solution out of pocket that plugs directly into your equipment or your existing design was actually crucial. And from there, creating that embedded no-code solution, we then took it a step further to create a solution and a software ecosystem that makes it very easy to configure our no-code devices, and then also to generate the mobile apps if they want to interface with a mobile device, or even the cloud dashboards that they'll need for visualization of data on the cloud. And then the final kind of last step that we recently took was to add into our device a Java virtual machine. That Java virtual machine means that with a very little bit of code, a few lines of Java, our devices can be integrated with any cloud platform, and we can actually, with that Java, handle the data formatting, the messaging, and the certificates that are required in order to interface with the cloud platform. On the other hand, we're not a cloud service provider, and that was an important aspect of providing that flexibility.
Exactly. Now, there were some changes in regulations around home appliances. Things like heaters aren't allowed to just have an on-on switch anymore. In order to sort of be ecological and energy saving, they need to provide the owner of the product the ability to switch them off and adjust them. So I heard you've been doing something in that area as well.
Absolutely, and actually it's one of our customers that brought this to our attention. Because they were faced with those European regulations. Clearly, European authorities are keen to bring us to a more sustainable future, and digital technologies and programmability is one of the steps that they can take to actually get there. Now, one of the challenges for our customer, LHZ, who's here in Germany, was that they implemented that in the form of an LCD on their heating product, and we have one here that we'll show you. And what they discovered was that actually fewer than 20% of users were actually using that functionality because it just wasn't easy to use or accessible. And that's an enormous frustration for a company like that and for their designers in particular. So they came to us looking for a solution, and using our modules, that no-code module, we're able to implement NFC in their baseline products so that that product interfaces then with a mobile phone, and you provide your user an app that provides more easy accessibility to the functionality, to the programmability of those devices, and makes it easy to understand what the appliance is capable of doing without having a user manual, and unfortunately those user manuals we lose very often.
Exactly, yeah. Fantastic. Well, there's some great technology there in IoT. It's really interesting to see how you're enabling that, and especially the no-code approach. Thank you for your time here at the show today, and we wish you all the success for the rest of the year, Steve.
Thank you very much, and pleasure to meet you.
Yeah, hi, so I'm Shreyas Derashri. I'm Vice President of Compute at Imagination Technologies. So Imagination is a semiconductor IP company. We have been in this space for over 2.5 decades now. Very well established GPU business. We have a market leading GPU position in mobile, automotive, and other sectors as well. So Imagination predominantly is semiconductor IP companies doing GPU IP. Then later on we started to focus on artificial intelligence accelerators, AI IP, and very recently we've just started to offer RISC-V CPUs, a complete compute offering for the industry coming from Imagination.
That's really interesting. Now, RISC-V has been a really big focus topic. We're seeing lots of RISC-V here at Embedded World. What's your position on RISC-V? What are you offering?
Right. So, as a semiconductor IP company, we just launched our first RISC-V IP core. It's a 11-stage dual-issue real-time embedded CPU. But we are offering a semiconductor IP. Plus, we are offering a complete solution with our SDK and our IDE called Catapult Studio. So that's our one of the contributions to the RISC-V space. The other thing that we are trying to do is encourage RISC-V in the industry a lot more and focus more on the ecosystem side of activities for RISC-V. So one of the things that we will try to do is implement only ratified extensions for RISC-V. Our belief is that the stronger the ecosystem grows for RISC-V, the more chance it has to survive and be more widely adopted.
Exactly. No, I totally agree. I think that standardization is key to keep it together. And from your perspective, obviously you allow people to turn RISC-V into semiconductor products. What sort of applications are making the most use of RISC-V at the moment?
Right, so at the moment there are small microcontrollers. Practically every semiconductor company they have almost switched to RISC-V.
Yeah.
We are now seeing more embedded processors coming out, more real-time application, more high performance, particularly from the automotive industry as well as some other AI-led applications, and that's going to be our focus as well, looking at mid to high-end processors in the automotive industry, potentially data center, but also bringing some of the other IP that Imagination has under the sort of same compute umbrella and giving customers a heterogeneous solution for the future.
Now, one of the big challenges for startups who want to develop innovative semiconductors is obviously licensing and the initial cost to get started. And obviously GPUs are a core part of implementing neural networks, artificial intelligence. How are you able to help them?
Right, so very apt question, Stuart, and this is something that we've been looking at very seriously. So very recently we announced our open access program. So it's a zero license fee, access to some of our technology that is being deployed in billions. So these are silicon proven GPU cores as well as our AI technology that we're opening up at zero license fee for startups and companies who want to enter and start to use GPUs in their products and the AI technology as well. So we just launched that program a couple of weeks ago, and yeah, it's available. It's called Imagination's Open Access Program.
And how can people find that if they want to find out more about the technology behind that?
Right. So the best place to start is our website, imaginationtech.com, and if anybody wants to reach out to us, reach out to the website, and we'll be happy to help.
Well, thanks ever so much. It's great to see you here at Embedded World 2022, and we wish you all the best with that program.
Thank you, Stuart. Nice speaking to you. Thank you.
Now, if microcontrollers are the brains of the application, it's power supplies that provide the lifeblood. I'm here at Traco Power to find out more what's trending in power supply technology.
Yes, yeah, great pleasure to see you again. It's the first post-COVID exhibition for Traco Power, so I'm very happy to see real people again. So yeah, Traco Power is a manufacturer of AC/DC and DC/DC converters. We are in the business since 1944 actually. So,
wow,
so
long time.
Long time on the market, 35 years specialized in power supplies. So we have a broad range of, let's say, standard off-the-shelf products, DC/DC up to 300 watt, AC/DC up to 1 kilowatt, and we also do customized solutions like, 5 kilowatt. We have 12 is the biggest I know. So just to give you an impression.
Yeah. So what are the trends at the minute? Obviously we've had a bit of a 2-year pause and not seen many updates. What trends are you seeing in power? What are your customers asking you for?
Yeah, I mean what is basically not exactly new, but what we are also seeing this year is that that the customer asks for smaller and smaller products. They want to have basically the same electrical power with smaller products, and this is what we see since a while actually. It's not particularly new this year, but we have been asked for this. Okay, do you have this power, this 100 watt, but maybe a little bit smaller?
Yeah.
And what we and of course we're listening to our customers. At least we try, and I think we succeed. And one outcome of this listening, I would say, is, for example, this 850 watt. AC/DC switch mode power supply. This is 6-inch by 4-inch,
wow.
Provides 850 watt, and until just recently, I would say in this form factor it was maybe 600 watts. So you can see it's like 30-40% jump. Absolutely. And where you can also see this trend is also in the smaller power DC/DC. So this is some of the viewers might recognize this as a 5 watt DC/DC converter, and today it could look like this. Incredible. with exactly the same power.
Yeah.
So this is, I would say, this is a trend, and another trend is boosted by the renewable and the electromobility applications, is that the demand for high isolation power supplies is rising. For example, this is a product which offers a 5,000 volt reinforced insulation, and you can have permanently 1,000 volt AC, which is quite above the normal industrial standard.
Yeah, super. Now, COVID's obviously been a big challenge. I'm talking to people all the time, and I follow Twitter quite closely, and we've seen like microcontrollers that are normally €6.50 being sold for €65.
Yeah.
Supply chain is an issue. How's it been for Traco Power, and how have you been handling it?
Yeah, I mean, it was quite interesting to see after the lockdown, beginning of 2020. I mean, this was let's say a difficult time business-wise. I think more. Apart from some medical suppliers, basically there was a dip in the business of basically the whole industry, and but on the other hand, it was interesting to see how fast the boom or the recovery has been since then, and with this recovery, which is basically a positive thing, but on the other hand, component shortage kicked in at the beginning of 2021 with availability issues, logistic issues driven by China COVID issues, and also increasing prices, for example. And what has helped us a lot is our traditionally big warehouse. We have a warehouse which is typically 25 million in products like this.
Wow.
So you can imagine there's a lot of products.
Yeah.
And this helped, and what really helped a lot is that the owners of the company invested at a time by end of 2020 where it was really difficult from a business perspective, but they said, hey, it will recover, and to be prepared for that, we invest in the warehouse, and this helps a lot.
Fantastic. Well, it's great to have caught up with you, Sebastian, here at the Traco Power stand, Embedded World. I really look forward to catching up with you again in 2023.
Yeah, looking forward to meet you, and it was a pleasure to talk to you, Stuart. Thank you very much.
Now, there's so much going on at Embedded World, there just isn't the time to talk to everybody you'd like to see. So now that I'm back in Munich, I've stopped here to talk to Luigi from Make My Board and find out about what could be thought of as a Raspberry Pi killer.
Hello Stuart, thank you for inviting me. Yes, I was at the Embedded World. It was a fantastic experience for me. Make My Board is a 5 months old company. It's based in Paris. I'm the solo founder, and I've been at Van Board to present this project, this product, which I really love it. I mean, it was my companion during the last year. And I had a great presentation with great people, a lot of fun.
Super. Now, of course, this is the thing that really came out of the Embedded World Conference for me, was that during the Corona lockdown, we've had sort of 2 years where people have been a bit restricted in moving and getting about, but engineers all over the country, they've been really busy generating new ideas and creating new things. So what have you been creating?
Yeah, exactly. It's exactly my case, frankly, because I had 2 years time to think about ideas and projects, and I came out with Make My Board, which is a do-it-yourself portal where people can customize design, and this is our first product, which I had the chance to develop together with the Thundercom team, which are really great guys providing really top-notch technology from Qualcomm.
Fantastic. And so what have you ended up with in this first prototype board?
Yeah, thank you for asking. This is actually Thunderberry 5. It's our first product. This is a new AI maker board, Raspberry Pi-like, based on Qualcomm next generation processor. This is the processor integrated in this board is an 11 nanometer, 8 core Qualcomm. Okay, it's the Snapdragon 7th generation. In addition to this board has something very new. 3 new things. First of all, a Microsoft module, this one from Thundercom. This module, Microsoft integrates processor, 4 GB LPDDR4 memory, 64 GB eMCC, then 2 PMIC from Qualcomm with 13 PMIC lanes for power.
Yeah.
The Wi-Fi module is even integrated. I mean, this is quite a lot of high tech. In addition, for the first time in the history, we integrated at Make My Board the Raspberry Pi RP2040 microcontroller, the very new microcontroller for Raspberry Pi, which is absolutely fantastic technology. I mean, third piece of technology is the Qualcomm acoustic. I mean, we integrated also this technology from Qualcomm, which is in charge of top-notch quality audio provided by Qualcomm Tech. Exactly. I mean, everything in a Raspberry Pi-like form factor, where you can connect the Raspberry Pi shields, everything you can find on other fruits.
Yeah.
I mean, it's quite a lot of fun. But the most important element of this board is that it is an AI maker board. It's the first AI maker board. What I mean is that you can connect 2 cameras from Framos to the board. One is here and the second is here. And there is even the possibility to connect a third camera. The camera are Sony Starvis camera, very powerful. We will support even 13 camera from Framos.
Yeah.
So it's kind of a very complex device where you can really build very complex system. And this is done for the maker community. I think, I think a lot of people will have a lot of fun using this device.
Now, you come from a hardware background, as we've been finding out chatting to you today, but obviously you've got a 5-month-old company and you're planning to do a Kickstarter program to launch this board.
Yes.
What are the missing pieces of the puzzle at the moment that you need to fill?
Well, software, guys, I really welcome, guys, because there is a lot to do in terms of software. The OS already supported is Android, Linux embedded, Yocto from Qualcomm.
Yeah.
Which also provide the Qualcomm AI stack. The new Qualcomm AI stack is provided. But of course, there is a lot of work still to do for Linux. I really would welcome on board Linux expert and especially also microcontroller expert.
Now, projects like this, obviously, as you said, require collaboration and people. And if people are interested in finding out more about this board and also your vision for this new way forward with AI vision industrial system, how can they get in contact with you?
Yeah, by LinkedIn. They can just reach me on LinkedIn, Luigo Grasso on LinkedIn, Make My Board, or going on this website, www.makemyboard.com.
Well, thanks ever so much for your time today, introducing the board, the Thunderberry, and we wish you all the best with the project, and we look forward to seeing how it develops over the next few years.
Thank you, Stuart.
Well, that's about it for Embedded World 2022. Everybody's going home, clearing up and tidying away after a very successful exhibition. We've seen loads of great new technology showing that COVID didn't quench everybody's innovation. They've been working on processing platforms in the cloud, time of flight, industrial networking, innovative power solutions, you name it, it's been here. And it's been great to talk both to the CEOs and also the engineers to find out how they've been bringing all that together. Stay in touch with us with Elektor Engineering Insights, subscribe on Elektor TV, follow me on LinkedIn, and who knows, perhaps we'll see each other at Embedded World 2023.